So we're going to look at physics objects again today. So let's make a new patcher, and we'll start with our standard jit.world with a toggle to turn it on. Here, I'll zoom in for you guys a little bit. And what we can do actually to make this window be easier to work with, we can add the parameter at floating 1, and that makes the window always float to the top. So this window will always be on top. Now that can be annoying if the window is in the way of your patcher, but you can just make your window a little bit smaller for now and put it over to the side. You can always still go full screen by hitting escape, I believe. If you click on the window and hit escape, you can go full screen. Okay, so now that window will stay up here. We want to actually name our world instead of dealing with this unique ID, because it'll help us. So let's name this world collisions, because that's what we're going to work with today. Collisions. So now I have a window, it's called collisions. My world is called collisions. All right, so you'll have to turn it off and back on again if you make any changes. Let's steal a few things from the help file to save some time. Open the JIT world help file. Let's steal our camera controls from here. These. And then also let's steal this stuff here. If you'd hold down shift and then drag around this stuff, the world box, get world box, prepend send phys, those items, copy, paste. If you have to go back and do them one at a time, that works too. And patch the send phys into the jit.world. Your camera controls should just work. What we're going to need also is our jit.gl physdraw. You have to put that into the same collisions universe to work. Collisions. Now we can see our world box will show up on our screen. Okay, we can move our camera now by, if you click on the screen, and now you can use WASD to move your camera. And Q and Z to tilt it. Right? Let's add the ability to change the size of our world box. Give yourself a little bit of room. I'm going to move this send phys down here and move these messages over, and I'm going to add a new object, PAK, P-A-K, world box underscore scale, and then float, float, float. Patch that into the prepend send phys, and then add 3 float number boxes. And make sure, don't patch this into the first inlet of the POC. You start with the second inlet, then the third and the fourth, right? Because we don't want to change the word. We don't want to change the word world box scale. We want that to stay the same. Now you can change the size of this world box to something else. Let's set it. It's by default. It's 555. Let's set it to 10, 10, 10. Okay, as soon as you change one of them, it's going to go back to 0 by default until you change all 3. Let's go ahead actually, and so we don't have to deal with that every time we open the patch, we can do a load mess 10 period. This will make, when you load the patch, it'll make a 10 come out of this. Patch that into each one of these things, number boxes. That way that 10 gets set right off the bat, but you can change it if you want.
or since those are float objects, does it auto-translate?
It would auto-translate. You could make it a. You could be a int just as well, because these will turn it into a float. Okay. So what else? Oh, let's add a JIT_physbody. So we have something in our phys world. JIT.phys.body, right? That's the physics object that we can attach things to, right? And if I move my camera in, there it is. I can't grab it because we didn't put in a JIT_phys picker. That's the only way to use your mouse to grab physics objects. JIT_phys picker. And you just need it somewhere in your patch, that's all. Now I can grab this and fling it around if I want. All right, now I want to direct your attention to this little pink indicator on the bottom of your physbody when it hits the floor. See, that is indicating a collision. Those only pop up in your phys draw when it's collided with something. So that data is there. We just need to figure out how to get it. The first thing you need to do is set the @collisions flag in your physbody to enable collision reporting. So @collisions1 will report its collisions. So if you have @collisions1 and you attach a message to it, the write outlet, the dump outlet of the physbody, it says collisions, dictionary, and then a unique ID. I believe that unique ID is actually the name of this physbody since we haven't given it a name. Let's go ahead and give it a name because that way we'll be able, when we add more than one body, we'll be able to easily tell them apart. Let's call this one just ball. So @name ball. So there we go. Wait, do I have a different patch open maybe? Collisions, dictionaries. Mine still says U47. I thought it would say ball at this point. Well, crap. Maybe it's because I have something else named ball. Let me just call it ball that way. No, that didn't work. Okay. All right, whatever. Doesn't matter. For now, leave it named ball. This will show up when we add another thing, when we add another body. Right now, it's actually just colliding with the floor. It's not an actual, we don't have an actual physical object that it's colliding with yet. This is the floor of the world box. The first thing we need to do is route for collisions. See how this says the word collisions and then the word dictionary and then the unique identifier. So if we route for collisions, we can get rid of that word collisions. Also, we can basically make sure that we're routing the collisions dictionary here, which is what we're working with. Collisions. So now attach a message coming out of that. Now you just get dictionary and then the name. What we can do now is to view that to work with this dictionary. You either have to use a dictionary object that will let you view it, like the dict.view object. Dictionaries are basically, I think they're like HTML files, HTML5 files that maintain a bunch of different properties in a hierarchical order. It's not a normal set of max messages. It's this kind of HTML5 file that this object can work. So this is a dict.view object. Dict.view. And it will show you the dictionary. So here are the dictionaries that's coming out of this. You have the ball, and see, it is called ball. I don't know why I'm getting this dictionary U50. That's kind of weird to me, because it should be called dictionary ball, because here it's called ball underscore wall body 2. Wall body 2 is the floor of the world box. If I bounce it against the side here, it said wall body 0. That's like the left-hand wall. Wall body 5, wall body 3. You can see as you fling this against different walls, it's telling you ball underscore wall body 2 or wall body 3. So this dict.view can show you the contents of the dictionary, and this can be useful for figuring out what you need to, how you need to process the list to get the data that you need. But you can't really get any data out of this particular object. It's only good for viewing things. And really, once you get your patch the way you want it, you probably should just delete this object, because it's probably going to make your patch slow down a little bit and doesn't bring anything to the table, right? It's just for analyzing things and getting things working correctly. All right? What you really use in order to get the dictionary contents into a list that you can process in a normal way in Max, you have to use the dict.iter. Stream the contents of a dictionary into a list. So coming out of the route collisions, we are going to put it in next into the dict.iter, which will iterate through the list and give you a series of messages. The last thing that it will actually, what you're seeing here is only the last message that it's sending. There's several messages that it sends every second. This is the last one that you're seeing. So this is now called the ball underscore wall body 2. Dictionary ball underscore wall body 2 is the last item coming from that dictionary. You remember this we had the same sort of format here, where we had collisions dictionary, and then the value coming from that dictionary, right? And what you can do is the same sort of routing. I could say route ball underscore wall body 2, and then have another dict.iter to get deeper into this, one level down. But if I change the name of this ball to something else, then I'd need to change that route object. So what we really want to do is just slice off the first item, no matter what it is. And there's another object to do that called zl.slice. ZL. So now we're talking about list processing, right? Because we have the dictionaries coming from the coming from the dump outlet on this physbody. And what we're trying to do is work with that information and process the list and slice it up to the right size parts to get the values out to actually do something useful, right? ZL slice is just one function of the ZL library of list processing. If you open the help file for ZL slice or any ZL thing, all of them open the same help file, which is just this ZL help file, process lists in many ways. So ZL slice is probably the most commonly used one, and that will slice a list based on the position that you give it. So if you say ZL slice 1, that'll slice the first item in the list off. And that means the outputs, there's 2 outputs on this ZL slice right here. The first item that's sliced off will come out this outlet, and everything else on the other side of the slice will come out that outlet, right? There are other ZL things I just want to make you aware of, like group. That's a really good one for if you have a whole bunch of messages coming in a stream and you want to collect them into a list. You can use ZL group. Like if you know that every fourth message is like a group of 4 messages, you can say ZL group 4, and then as messages come in, it'll dump out lists of every fourth message, or a group of 4 messages, right? So you can play around with these. We'll look at these again later, but for now, we're just going to use the slice. So we have a ZL slice 1. So coming out of this dict.iter, we can ZL slice 1, and now we should just get ball underscore wall body 2 coming out this outlet, which we can actually use this to indicate contact between 2 bodies. This case of the body called ball and the wall body 2. This may be all you need to trigger events in your patch, right? Because as soon as where is my ball? It disappeared. Let me delete it and undo, and there it is. So as soon as this hits something, I could, select for this maybe. So like select ball underscore wall body 1 with a bang. And if it hits that wall, boom, see, I got the bang, right? And that's all I needed for a collision. Boom, right? So maybe that's all I need. But what this wouldn't do, what this would do actually, so say you're doing it for wall body 2, the floor. See how it's constant? Because this is in contact with the floor, so this is constantly triggering. So that might be a problem if you're just want it to trigger the first time it hits the floor, or every time it bounces on the floor, make a sound or do something, right? Then this triggering constantly would be a problem. So what we can do to do that is drill down into this dictionary and get to the values having to do with duration here. See how this duration, this is how long it's been in contact with that body. And we can use that value to either only let values through when the duration is 0, which is the first time it makes contact, or maybe we want to, after it's been in contact for 10 seconds, cause an explosion, like the floor is made out of fire or something, right? So let's look at how we could do that. So far, we've just sliced off the first value, which is the 2 bodies that are making contact. The rest of this list is that dictionary still. Dictionary ball wall body 2. I can't say that. So now we can dict.iter that as well to get all the values from that. And now it'll give you a list of all of these values that are displayed here in the dict.view. You're only seeing impulse because, as you can see, impulse is the last value in that dictionary. So it's very quickly going ball, body 1, body 2, position, normal, contacts, duration, and impulse. But you're only ever seeing the last message because it's updating so fast. So we're going to have to now route for this. Here, let me make my window smaller so you can see what's going on. So now we just need to route for duration. Route duration. And now we get the actual duration that it is in contact with whatever it's in contact with. So say we wanted to make a cool thing that say it's like a hot potato type game or something where if the object is in contact with the floor for more than 10 seconds, then it explodes off the floor in some random direction. That's actually not that hard to do. we have our duration right here, and you see as soon as I pick it up with my fizz picker and drop it, that duration goes back down to 0. Right? So let's see. We can say greater than 10. And that will give us a 0 or a 1. Right now it's a 1 because it's more than 10 on that duration. We're going to want to send that through a change object so that we don't get a million ones. We only need it to trigger when it changes. So then we should get a 1 when it's greater than 10 seconds. So we can say cell 1. And then that'll give us a bang when this has been in contact for greater than 10 seconds. So see the duration coming in. As soon as this goes to 10, you should see that bang. 7, 8, 9, bang, right? We can use that bang to create an impulse message that we send to the physbody to make it move, right? So let's make an impulse message. P-A-K, impulse, float, float, float. The 3 floats are the force vectors for x, y, and z. Let's create a random force vector. So we can use a random. And I think a good range of values is somewhere between 0 and 20. We don't need to really hit these things super hard. So random 20. And patch that into, skip the first inlet of the POC. And you can patch the output of this bang or the cell 1 into all 3 of the randoms. You can actually move this down here. Right? And then send that message now up to the physbody. And so now, if I'll make my window a little bit bigger. If I drop this on the ground, it'll stay on the ground, and after 10 seconds, it'll trigger an impulse that'll make it explode in some random direction. 7, 8, 9. Wait, why? It didn't work. Maybe I do. Maybe I have to have a floor body first. Did it not trigger?
Is it infuse or impulse?
Impulse. Thank you. I had a typo. All right. 6. All right. Oh, I moved it. Hold on. 1, 2, 3, 4, 5, 6, 7, 8, 9. Bang. There. Right? What we could do is we could always make sure it lofts off the ground some amount by saying, let's say that we'll change these to like random 25s. And then leave this one here in the middle as random 20 and add +5 to it. So that way it's always at least +5 on the Y. That way it will always go up a little bit. That's some amount. Every time we bang this, we get a random force vector. Okay? So that's a system now that is reacting based on duration, right? And we're saying over 10 seconds. So if it's been in contact with anything for over 10 seconds, then apply a random force vector. This isn't specifically telling us at this point that it's in contact with the floor. The floor is the most likely object because of gravity pulling it down. but this would just as if I changed gravity to pull it up, this would work the same on the ceiling as the floor. So we could change our system to look for a specific interaction, like I was here between ball and wall body 2. But let me show you something that's a little interesting about this. So if I'm selecting for a particular interaction like ball underscore wall body 2, that's all good and dandy as long as it's ball wall body 2 and not wall body 2 underscore ball, which it sometimes is, and I haven't been able to find a way to force it into a particular orientation. It's always whichever one was named last when you're spawning objects. So if I change this to ball, if I change it to something else like ball with one L, that was the last one that was thing. So this is now called ball underscore wall body 2. And wall body 2 is always going to, oh, this is not a good example because I need to have a new object. Let's go ahead and just add a new object. We need to do this anyway. A new physbody. Just duplicate this and call this floor. And what we can do, we actually want to change the floor physbody to be a cube. At shape, cube. At scale, what? 10, the size of the world box. 10, actually 10, 0, 10, I believe. Yeah. And see here, when I spawned that, it made this thing here, but we actually need to make this kinematic because we want it not to move, and we need to specify its position instead of letting it fall to gravity, because right now it's actually on top of that ball. So we can say at kinematic 1, I believe, and at position 0 period negative 10 0 period. There we go. Now it's down at the bottom. So now now you can see that it's created an interaction dictionary called ball. Let me put the 2 L's back in here. Ball floor. And this is now called, because I changed this to ball with 2 L's, it's now called floor ball, right? So if I just was to change the name of this floor body here to something else like floor 2, now that's the last one that I created. And so now the dictionaries are called ball floor 2. They can switch around is my point. I don't know that they did this time. See, there, I changed it. Now this is called floor 2 ball, right? Floor 2 ball 2. So sometimes if you're looking for a particular interaction between two things, it could either be called, it's always the first body underscore the second body, but those might be in different orders. So you can just select for both variations of it and you'll be fine. Or you can do some searching the data string, which is what we're going to look at here in a second. So right, I can say, so say I wanted to select for the ball hitting the floor. I'm going to go back and rename my thing back floor. I don't need to call them floor 2. So I have one called ball and one called floor, right? That's why we named these with an at name. So I can select for ball underscore floor, and that will bang every frame that it is in contact with the floor. I could also, just in case, do the reciprocal floor underscore ball, because sometimes it will be in that order, especially if you're like editing your patch. You know, in this case, I can probably, if I were to respawn these objects, I could make it be the other one. See? Now it's the other one. All I did was delete this and put it back, and now it's that one. And if I delete this and put it back, now it's this one, right? So it might be one or it might be the other, but you can just select for either case in your patch, and that you can use that as a trigger. But the thing here now is that we are triggering on every single frame that they're in contact. And what if we only want it the first time that they make contact? So that's the next thing we want to do. So we have a system here that is measuring how long they're in contact. And when it's over 10 seconds, that's triggering an action of creating this impulse. Right, that's what we're doing over here. Actually, I'll leave a float here so you can actually see that value as it counts up. Right? But what if we wanted to only work with the value when it first made contact? We can do that by doing a slightly different math operator here. So instead of saying greater than 10, say equals 0, period. Okay, so this will only send a 1 when something first hits something else for the first time. And if I toggle this, if I put a toggle, you might be able to see it toggle, but you might not even see it. You probably won't even see it because it's so many times it's more than it's 0 way more often than it is, and it's only 1 for a microsecond, and then it's replaced by a 0, so you never even see it. But it's there, and we can use it to create a gate, to open a gate, and only let values through when it's the when it creates the thing. So what values do we let through? We could let a duration through. That would probably work and just trigger on that. But we could also use this first thing that actually tells you what the interaction is that we sliced off way back here, right? If we pass this through the gate, then only when it first makes contact, we will get what the two bodies that made contact are. Boom. See that? And I could just use that. I could ignore what that is and just send it to a bang and use that to trigger like a sound, say. Go ahead and grab an audio file. I don't know if you have the same audio files as I do. Let's see, symbol. That would probably work. Or what? Ding. What do you guys have? Do you guys have a kick? Do you have this kick or a clap? I think I have a clap in mine. You have kick. I heard somebody else play it. All right, let's start with that kick for now. Drag the kick 01, drag it in there. And you're going to need an easy DAC. Right? And how do you get these to play? You send it a message of some type. Does anybody know? Send it a 1. Right? So all I have to do now is attach that to the bang that I created. And now I should get a bang every time it hits a wall or the floor body. But only when it first hits. Right? What if we want this thing to bounce more than it is? There's a couple things that are keeping it from bouncing. there is built into the physbody by default, or is damping. Damping, both angular damping, which will slow down rotations, and positional damping, which will slow down movement. So we can turn that off first of all. So you can just, if you want, just do a truey here for damping. See where the damping by default is 0.2. So we can change that to 0, at least on the, you can go ahead and leave the angular damping at 0.2, but change this first value to 0. And we should probably actually just put it in the physbody attributions so that it doesn't change. At damping 0 period 0.2, like that. Okay. So that's the first thing. So it will now it doesn't get dampened by, its motion doesn't get dampened, but there's another thing that's affecting it, and that's called restitution, which is how much energy is maintained after a collision. And by default, the restitution on these is very low. Let's see. Find the attrui for restitution. Yeah, it's like 0.1. So the restitution is affected by both the object's restitution and the restitution of what it hit. So if we put this at 1 and we put the floor bodies at 1, then it should bounce without ever, it should have as much energy coming out of the bounce as it had going into the bounce. So let's add these to the attributes. So at restitution, and it's easiest just to click it out of the list after you start typing it, restitution 1 period, and then do the same thing on the floor body here, at restitution 1 period. And now you should be able to make this bounce off the floor, and its bounce won't decay so fast. Is that working? Is anybody's not working? Okay. What's the problem? First of all, where's your floor body? Doesn't look like it's in the right place. What's the size of your world box? Bet you your world box is 10, is only 5. Change that to 10 on all of them. Just type it in. There. Now is your world, there you go. Right? Yeah. So you cannot adjust the restitution of the world box walls, only phys bodies. So if you want things to bounce forever, you have to have a floor body in there at kinematic 0 so it doesn't move, and then have a restitution on that. You can make restitutions be greater than 1 too. You can have it have more energy coming out of the bounces than it had coming in. Kind of make exotic matter or something. Yes? Weird. Well, disconnect the thing that's triggering that 1 for now. Yeah, just disconnect it. Turn your sound on after you get it disconnected. Turn your sound on. Turn your sound on. I mean, click the easy deck. And click. All right, now click the 1. Oh wait, what? Why is it turning off? Yeah, because the easy deck is off. So I think there's a problem with your DSP. think it's under Windows. Options maybe. Yeah, audio status. Okay, so driver, I don't know what that is. So it might be that you have a weird sound driver that's not working right. Okay, so make sure that's it. Alright, then turn that on in the corner. Does it go off? So I don't know why it's turning off. Are you sending a 1, 2? No, you're not. I don't know why.
Yeah. Oh, I'm
It
just
should be turning off.
trying this.
It makes me think that it's turning off because the audio isn't working. Alright, is anybody else having problems? Does anybody else need help? See, I'm not exactly sure how to solve your issue, Si. I think it's a driver issue of your sound. Alright, so you haven't changed the size of your world box. It's still 5, but you have this below the world box.
Oh, okay.
Change your, put those as 10 again. Yeah, I guess. Just change that first box to some other value and then back to 10, and that should set it to size 10. There you go.
Oh, okay, great.
Cool. So I've never really been able to get, you would think that if you have no damping, you set it to 1, the restitution on the other body is 1, there should be no energy lost and there should be no energy gained, that it would bounce forever at the same height. But I tend to find in this engine that it's never quite perfect, that over time it will eventually either lose energy or gain energy. Mine's gaining energy and is hitting the ceiling. So if you want a perpetual motion patch, that can be a challenge. You might have to have some sort of system that adds energy surreptitiously back into your patch. But if you want the ball to eventually stop bouncing, that's easy enough. Just make the restitution somewhat less than 1. Or you can make your restitution be greater than 1 and have dampening of motion dampening of some kind. So a lot of times, like by default, the damping on this is like 0.2, which will inevitably slow this thing down. Right? It's going to slow down over time because it's like wind resistance. All right, so we can patch this into a physbody. Not physbody, a JIT GL grid shape. Right? And let's make the grid shape be at lighting enable 1, at lighting enable 1, at smooth shading 1. Oops, not smooth shading 11. Right, and all we have to do to make these be attached to each other is attach the physbody to the grid shape. And there we go. So now we have this ball that can that moves around and bounces around, and if it sits on the ground for more than 10 seconds, it gets agitated back into motion.
What was the last part of that?
What? At smooth shading 1. Right, and we can color this by sending at color messages. Color 1 period 0 period 0 period should make it red. Right. Cool. All right, so we have about 40 minutes left. What I wanted to do now was to encapsulate this into a sub patch that we can now spawn as many of these balls as we want, make them each independent colors, and not have to worry about and have all this dictionary sorting in the sub patch so that we don't have to build it 25 times, right? And we're most of the way there. So we have coming out of this, all right, let me turn off my sound. Stop driving me crazy. We are routing for duration. There's one other thing we can route for. There's a few other things you can route for. There are anything that's listed in this list, right? So there's normal. That has to do with what direction is up. In this case, we don't really care on that, so that's not that useful. Contacts is how many different objects is currently touching the object. That might be useful. I'm not going to use that in the patch today because that would be kind of time consuming, but say you wanted a patch where if you had 5 of the balls, if they all got together, or 4 of the balls, if they all got together, then that explodes or something, right? You could route for contacts, right? So I'm route duration. I could say route contacts. And what's the other one? Impulse. And that's how much force is coming off of the rebound, which I think that is probably, other than duration, that's probably the most useful other thing in here. So, right, contacts. This will show how many contacts are coming out. In this case, there's only going to be 1. But the other thing is impulse. So it's going to be 0 while it's in the air, but as soon as it bounces, it'll be some value above 0. And that is representative of how hard the thing is bouncing off of the ground. So you could do something like greater than 15, say, and then if it's bouncing off of something really hard, it makes a different sound, like a crash sound, or it explodes or whatever. You would want to do the same thing you did here, actually, where you're using a change and a cell 1. Sorry, I'm trying to clean this up. And let me move this over. This goes, there we go. That was what we were using for the gate. Okay. So now if this hits the ground with a rebound that generates a rebound force of over 15, then that bang will fire. So if it just bounces off the ground, it doesn't trigger. But if I throw it into the ground really hard with my mouse, then it does trigger. Or maybe that's not enough. The 15 seems to be triggering them too much. So maybe I make that 20. So as you see, as it's bouncing right now, that's not triggering. But if I throw it into the ground with my mouse, then it does trigger. Right? So maybe I have a different sound for that. Let's see. What do I have? I think there's one called Eroica, which is like a Eroica, which is like a symphonic hit. So say if that triggers, then it plays this sound over here. Right? So when it's bouncing, it doesn't usually trigger that, but if it hits it really hard, it will. Right? Or maybe makes a cutesy baby sound. Right? So now so as you can see, you can use the different the different information contained in this dictionary to trigger different things based on different conditions. All right, so let's encapsulate this into a patch so that things don't get so crazy. So let's just leave this open. Go ahead and let's save this for now. Let's save this. Call it collisions. And make a new patch, because we're going to have this be an external patcher. You can leave this open for now. Where's my new patch? New patcher. There we go. All right, and let's see. We want to grab the body. Let's see. We don't need these attrues anymore. Those were just for looking at things. We want to I'll turn off the sound on mine. We want to grab the body and the grid shape, all this stuff down at the bottom, not the sounds. So everything except for the sounds. All that stuff. Copy and paste that in here. No. Just the physbody. That's not it. What the heck? I copied the wrong thing. Hello. Darn it. This stuff. So physbody, the routing, the grid shape, all the routing that we did here, the gating, but not the stuff having to do with sound. We don't want that as part of this patch. And copy it. And hopefully I actually got it copied this time. There we go. And paste it in there. All right, so we have this sub patch now. We don't need this anymore. Let's see, this grid shape. Let's move the grid shape out of the way. There we go. Let's get rid of that color message. I'm just rearranging things, making it look a little neater right now. Don't need that. We don't need these. These were just other ways I was showing you of selecting things. There we go. Wait, actually, let me do it this way. Duration, contacts, impulse, that's right. Slice 1, that's right. Collisions and enter, yeah. Okay, cool. So now we're going to need some outlets. Outlet. And we're going to have 3 outlets. And oh wait, we don't need this random stuff, right? That was just a special function we were building. Let's see. Yeah, sorry. We don't need this stuff with randoms. So get rid of that. Get rid of the greater than 10. We need this over here. We need the equals 0. There we go. And that makes this much simpler. Make it like that if I want. Okay, got that? So we've stripped off a bunch of stuff that we don't need. This was number of contacts. We don't really need this. Let's leave it in for now. We can add to this patch later if we want to do something with contacts, but I don't need to send this anywhere yet. On this impulse, we don't need this stuff. Let's simply send that out. We just need another gate. We need another gate just like this. Doesn't need to be this big though. and patch that 1 into this gate as well. So when the duration is 0, that'll open up the gate that lets through both the name of the two objects that are hitting each other that we sliced off here, and then through a different gate it will open up and let out the impulse, which is how hard they're hitting each other. So we can send the two objects here, the impulse thing out this outlet, and greater than 0. Hold on. Yeah, that's right. Okay, cool. And then for the third one, what I want to do is actually, we're going to look at the message and figure out what the other body is. So this first message is going to be the two-body interaction. So it will say ball underscore floor, but it might say floor underscore ball, and we don't know which one it's going to be, right? So there's a way that we can search that message and give us the other term, whether it's either before or after the search term. And that's using a thing called regular expressions. And I wish Charlotte was still here because she was the one who was interested in searching text. Okay, regular expressions, which is regexp. It's kind of a weird object. Open the help file for it. You have to give it an expression that it searches to find things. And if you go to examples, it shows you some examples of how that works. So you look at this and you're like, what the heck is this? That's completely incomprehensible. But essentially, if you look at the meta characters, these are mostly what you'll be using. And you can search for a particular thing. So like if I was searching for ball, I could say regex ball. And if I sent the word ball underscore floor to this, if there are multiple outputs, and I believe you would want substrings, so the third output, if this has the word ball in it anywhere, it'll output that substring out of it. If this didn't have the word ball, so if this was like, I don't know, fire underscore floor, nothing's going to come out, right? There's nothing. If I get rid of this message, I send fire floor, nothing's going to come out, right? So you can use regexp and what you're looking for, and it will trigger an output if that exists in the message anywhere, right? So this could be ball, and it should still give me ball because ball was in there. Okay, so that's a really cool way of searching a collection of characters for a particular string. This can be a different message every time. It can be the same message.
It's not resetting. It's not going to nothing.
Did you clear that out?
No. Sorry.
So yeah, I mean, a message is nothing is coming out, and a message doesn't get updated unless something comes into it, right? But you could. That's why I attached a button here, so you could always see something came in there, right? Or nothing, right? If I send the word bang, nothing is coming out because there's no ball in that. But if I say ball bag, then I get the ball, and you can see that's coming out everything because it has the word ball in it. So I could just do regex ball, and that should always trigger if there's an interaction with the ball, with the thing ball. But It'll also trigger, if I have more than one ball and I have ball 1, ball 2, ball 3, ball 4, it'll trigger for all of those because ball 4 has the word ball in it, right? So what we want to actually do is search for a particular, we need to create the expression that searches for the name of this physbody. And first of all, we want this physbody, we want to be able to have independent names every time we instantiate this external object. How are we doing on time? Okay, good. So remember when we did patcher arguments, we can say #1, and that will get replaced by whatever we put in the patcher. I don't know how I got a pipe symbol in there. It should just be #1. Right? So now when we name this, we'll name it ball, and that will be that #1 here will get replaced by the word ball. What we need to now do is have a regular expression that searches for the word ball, but we'll need to be able to get that name from it. And to do that, what we can do first of all is we can set a load mess with the same patcher argument so that when this is instantiated with the patcher name ball, this load mess will spit out the word ball. So we can send that to the regular expression. Now, in order to update a regular expression with a new expression, and we should, because this is changing, we should give it no expression to start off with. Just call it regular regexp. The message you sent is RE and then the expression. Now, how do we create, what expression do we need to send it, and how do we create that? We need to send it, so we could just send it the word ball or whatever we call it, and then that will kind of work. But what we want to do also is we want to find out what the other body is, because that info might be useful to us. And we don't know whether that other body is going to be before the word ball or after the word ball, because sometimes it switches around depending on what body was spawned first. So this is going to spit out whatever we name. We can then create an expression with that using an object called sprintf, which will allow you to create a formatted message from objects that come into it. And if you open the help file for sprintf, you'll see that this uses its own syntax, and it uses percent signs, and it likes to do like percent LD, which is like a decimal digit. Sprint.2 is a float with two precision points after the float. We're going to actually use symbols, which is percent S symbol. So we can say sprintf percent S, which should, if this is going to, so just to test this, say this is called ball. If you said sprintf percent S, then that should just give you the same word out as you put in. Gives you ball. But what we will need to do is search for characters before that and after that. And we don't know how many there are, and we don't know, we just know that the word ball is going to be somewhere in the middle. So in regular expressions, there's a couple of, so far we've just been searching for the, doing a basic search where we're matching one term, and then if it matches that, it comes out of this substring third output. But there's two other outputs that we can get matches from, and that's called they're called back references and substitutions. Substitutions can be used to substitute one word for another word, so I can take out the word ball and substitute fire if I want. That in our case isn't that useful. What we want to do actually is we want to use back references. And the way back references work is by putting things in a parentheses. Anything inside of parentheses, if it matches characters inside the parentheses, they'll come out the back reference outlet. So we can use this to search for basically two different things at the same time by having a main search term and a back reference search term. So inside the back references, we'll need, we don't know what the character is. So the character for an unknown character is dot. So that means it can be anything. We also don't know how many characters are there. So it could be it could be 0 of those characters, or it could be more than 0. Ball could be the first word. In that case, there would be 0 characters there because ball is the main search term. But ball could be the second word, in which case there might be some amount of characters, and those characters are whatever we have the second body's name is, right? And we don't know how many characters there are. So there's a shortcut for that. If it's 0 or 1 character, you use the question mark. If it's 0 or any amount of characters, you use this star. So that's what we'd use. So we're creating the message parentheses, dot, star, parentheses, and then the word, the name, ball, right? And then the same thing on the other side, because it might be on the other side. So parentheses, dot, star, end parentheses, like that. So that's the message that we have to create. And so to do that in the sprintf, all we need to do is substitute, just put this thing here, but put that %s instead of the word ball. So I can go here and paste that in, but take the word ball and change that to %s. So see, sprintf dot star open parenthesis, dot star, close parentheses, %s, open parentheses, dot star, close parentheses. Now it creates that message. Then we actually just need the word RE right before that. So we can actually just add that to the sprintf. We can say RE space like that. And now the word ball gives us that. So if I now patch this load mess, which will have the word ball in it, if that's what we have the thing named, we can patch that into that sprintf and then patch that into the regular expression so that it gets the expression that it needs. Then we can also, let's see. So then if this is ball, say, and we can use this first slice, right, which had the names of the two bodies, and patch that into the regular expression. Then when we get those bodies, am I not getting anything out of that? Let's see. Oh, right. I'm not getting anything because this isn't attached to anything yet. That'd be why. Yeah. Sorry, this won't work until we actually use it. So we'll look at that in a minute. This should work though. According to my notes, this should work. And we'll look at how it works in just as soon as we spawn it into our patch. That will output the message here. Let's just save it for now. So save this and call this subpatch, what do we call it? Collision ball. All one word. Make sure you don't have any spaces. Okay, now go ahead in your patch and you can spawn that external in your patch. We can actually, let's just delete all this now. We don't need this stuff anymore. And instead we spawn collision ball. There it is. Open this up. Now we should be able to get this on there. All right, so, oh, we didn't give it we need to give it a name, right? That was the one thing that we added. So collision ball, we needed to give it a name, ball. There, okay, cool. So now you can see that this is the regular expression is searching through that and is giving us the word ball. Ball wall body 2 here. In the back references, it should be giving us the other body. So in the not substitutions, back references, the second one here, there, that's the other body, is wall body 2. It's also giving us that underscore. We need to get rid of that underscore. And again, we're not going to know whether that underscore is going to be before the wall body or after the wall body. So we have to do another regular expression, but this one's really simple. All we have to do is do another regular expression and say regular expression space underscore. So we're just searching for underscores and at substitute %0, which is a special character that means substitute nothing. And that will actually strip off that underscore and give us just the other body. So now if I attach this message to this regular expression under the substitutions, it gives us just the word wall body. And it doesn't matter whether that is at either the beginning or the end of the word wall body. Right? So this should be your collision ball object. Oh, you know what? We opened another view of this, didn't we? Instead of opening the original. Does it matter? I think if you save it now, it'll overwrite these things. Just we only made one quick change. Let's just close this. Don't save it, and open the collision ball separately. Open recent collision ball. We are at time. This is the last thing we'll do. All right, so all we did here was, what did we do? Oh, right. We have another regular expression. Just duplicate this right here. And we said underscore and then at substitute %0, like that. And you patch that into the back references output of this regular expression, the second outlet. And then patch that into the outlet. And then that should be, if you save that, that will give us the name of the other body will come out of that. We don't need this extra stuff now. This was just to show us how this worked. Save this, and now we can take a look inside of this if you want. You actually don't even need to. You can just put a message outside of it. You should get what it hit here, and you will get the two body interaction here only out of the first inlet only when it first makes contact. So you can use this to trigger things just by using a button instead of the message. That will only trigger when it first makes contact. Right? And then this is what it made contact with, and this is how long it's made contact. So if this stops completely, yeah. Oh no, that's not how long it made contact. This is actually the force the rebound force that it has when it's bouncing off of it. Right? So that I threw it down with my mouse and got a really high value. So you could use that to trigger something based on force. All right, so your homework is to do something interesting with this. The only thing we didn't do in this patch that I meant to do was add some stuff like to change the color, and I was going to do some skybox stuff, but I think you guys can figure out how to do that yourself. So let me just show you really quick. If you open back up your external patcher, right? We used a #1 for the name here. We could use #2, 3, 4 for color stuff. So like you wouldn't want to color the body, you'd want to color the grid shape. So I could say #2, or sorry, at color #2, #3, #4, 1 period. It's always going to be full opacity, I'll say. So then as soon as I save that, it made the ball black because I haven't given it those values, and so it's making it. So now I can specify what color to make this. It doesn't matter there. Right? Now it's a red ball. And I could call this red instead of ball, and now I could have a red ball and a blue ball or something like that. And maybe in your patch have a special interaction when two balls hit each other rather than the balls hitting the floor or something. Come up with some interesting way of working with either duration or things hitting each other or how long they're in contact with each other. Okay? And have more than one, have one floor body and have more than one ball or other shape. It doesn't have to be a sphere. It could be whatever shape you want. There's other grid shapes you could use, like torus is a donut shape, or a capsule, which is like a pill shape, or a cube. You could make a dice throwing game, something. Okay? Cool. Sorry I didn't get quite as far as I wanted to today. There's only a few things we didn't get to, but nothing. We got everything major.